All right, in geometry today, we're going to introduce lesson 5.5, and the topic in that lesson is called trapezoids. And remember, in this chapter so far, we began the chapter by explaining parallelograms and what the properties were, such as the opposite sides are congruent, the opposite angles are congruent, the opposite sides are parallel, and we know that the diagonals bisect each other. Then we got into quadrilaterals and special types of quadrilaterals like rhombuses, squares, rectangles, and all those have their own properties as well. Now here we're going to talk about trapezoids. Now to start off with, let's just go over what the definition of a trapezoid is. So you'll write this down. A trapezoid is simply a quadrilateral. A quadrilateral, remember, is a four-sided figure with exactly one pair of parallel sides. So a parallelogram and a trapezoid are similar in that they're quadrilaterals, but they're different in that, remember, a parallelogram, both pairs of opposite sides are parallel. A trapezoid, you only have one pair of sides parallel. So if you look at these two examples, the parallel sides are called the bases. So I have two trapezoids here. And notice in both these trapezoids I have one pair of parallel sides, and they are called the bases. Now the sides that are not parallel, okay, we call those the legs. So make these two diagrams, label them, and make sure you understand the difference between the bases, which are the parallel sides, and the legs, which are the non-parallel sides. Now as we continue here, a special type of trapezoid is what's called an isosceles trapezoid. So if you take a look at this diagram along with the definition, an isosceles trapezoid. Now we've had isosceles triangles, right? An isosceles triangle is a triangle that has exactly two sides congruent. Well, an isosceles trapezoid is similar. An isosceles trapezoid is a trapezoid with congruent legs. So notice what I have here. I have my two bases, right, which are the parallel sides, but then I have the two legs, which are congruent. And that makes it an isosceles trapezoid. Now if I go back to the previous screen, notice in these, the legs in these aren't congruent. Maybe they may be here, we don't know. Okay? But some trapezoids do have congruent legs, and those are called isosceles trapezoids. Now, a theorem that follows the definition of an isosceles trapezoid is theorem 518. And it says the base angles of an isosceles trapezoid are congruent. Now, what do we mean by base angles? Well, notice that I have my two yellow sides, which are the congruent legs, right? The base angles would be the bottom angles. Those could be the base angles, so they would be congruent. So, for example, I'm going to label this A, B, C, and D, and you do the same. So in this situation, if this is an isosceles trapezoid, then angle A is congruent to angle D. Now, also, these are base angles, right? So the bottom two are base angles, the top two are base angles. So we could also say that angle B is congruent to angle C. So both these would be true because both pairs are considered to be base angles. Now what we call the median of a trapezoid. The median of a trapezoid is the segment that joins the midpoints of the legs. So again, just to reinforce this, I have the base sides, which are the parallel sides, right? And then I have the two sides that are not parallel, okay, the legs. Now, if I got a segment that joins the midpoints of those legs, so say that I know this part equals this part, and maybe this part equals that part, right? So in other words, this point right here and this point right here have to be the midpoints. The segment that joins the midpoints is called a median. And remember, it's got to connect the midpoints of the legs. Now, what happens when we have a median? Well, let's take a look at theorem 519. Two things happen. And this looks familiar with what we had with the segment joining the midpoints of the sides of a triangle. Okay, the median is parallel to the bases. So I'm going to mark that here. So I know that this median is parallel to the two bases, and it has a length equal to the average of the base lengths. Remember, in the green I have my bases. Now, to find the length of the median, you average the two bases. So say this base is 10, say this base is 4. You average the two. So to find the length of the median, I take 10 plus 4, and I divide by the two bases. There's two bases, so I divide by 2. So I have 14 divided by 2, and I get an answer of 7. The median is 7. Let's go over just one more example, and then we'll finish up. How about if the two bases had lengths of, I'll say 12 and 10? Well, we'd add 12 plus 10, and we divide by 2. So I'd have 22 divided by 2, or in other words, the length of the median is 11. Now, certainly there's times where you're going to get decimals. You know, say you had a length of 7, and say you had a length of 4. Well, 7 plus 4 and divided by 2. So I'd have 11 divided by 2. I'd have 5.5 or 5.5 for the length of the median. And that is that's all that we have in this section. And the focus of this section is called trapezoids.